Hey, hello friends. We have another coding challenge today. We're going to look at the Fibonacci sequence. For those of you who don't know, the Fibonacci sequence is a list of numbers like this, starting with 0 and 1, where each number is the sum of the previous two numbers. So 0 plus 1 equals 1, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, etc., etc. We're going to do two things, two different functions. Given an int, return the Fibonacci number at that location. And then the second one, given an int, return all Fibonacci numbers, return that many Fibonacci numbers. So let's just jump in. So the first one's a really good example. I feel like a classic example of a recursive function, meaning that this function, well, practically meaning that this function is going to call itself in order to complete the task. So give it an int n. We need our base cases where, if n equals 0, we want to return 0. And then if n equals 1, we want to return 1. This is going to stop our recursive function from going forever. And then all we need to do is call the number, this function with the number before the integer we were given plus the number 2 spots before the integer we were given. And that's it. This is a very elegant solution to this problem. We can go ahead and check this. If we want, let's say, the 5th number, or rather the 6th number, we'll start with 5, just because we start at 0. We can see that this gives us the number 5. So we can see 1, 2, 3, 4, 5, 6, which again, since we start at 0, 5 is the 6th number. Let's see if we do 6. We get 8, 7, 13, etc., etc., etc. We can do 11. And there we go. Now, obviously, this function calls itself, so it's exponential. The time complexity is an exponential time. So that means that the bigger the integer that we give it, the more times it has to call itself, meaning it'll get really, really slow, really, really fast. There we go. We put 40. That took a little bit. And if I put 50, I think I break it completely. And I'm not going to sit here and wait for it. It is doing calculations in the background, but I think there's another issue that we will see with our next example. So now what we want to do is return all Fibonacci numbers up to a given integer. So what we want to do, static, is we're going to return a list of integers. Let's call this fib2, n, and we are going to initialize our Fibonacci sequence where we have the first two members in the sequence. And then what we're going to do, we need some kind of list of integers. We're going to call this results. New, we'll make an array list. Whoops. And that's what we'll return. We'll use that to complete this challenge. While I is less than the number we're given, and then increments our iteration. So the first thing we want to do is we want to add our first number to this list. Then we need to change all these numbers. So what we're going to do is create a temporary variable called just next, and that's going to equal first plus second. So 0 plus 1 equals 1. Now we're going to swap these around. So now first equals second, meaning now 0 equals 1, and then, and then second equals next, which in this case is just going to be 1 because it's the first plus second. So now first is going to equal 1, and then second is going to equal 1. In our next iteration, we'll see that that'll give us 1 plus 1 is 2, and then we'll have 2 plus 1 is 3, and then we'll have 3 plus 2 is 5, etc., etc., etc. And that's it. So now we just need to return our result, and then we should be able to see let's get up to 10. So we have 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, sorry. And there we go. Now, this one isn't going to have the same time complexity as the other one. You can see that it's actually going to return this super quick. We can get this, but there's a problem that we're going to have real soon here. And maybe, again, if you're here for learning purposes, I would say pause and try to understand what's going to happen when I run this, when I check what the 50 numbers in the Fibonacci sequence are. If you're not familiar with computer science, something really, really weird is going to happen, and it might be a little confusing. But this is an important concept to understand. I don't pretend to be an expert, but it's important to understand these things. So we're trucking along, and we can see that these numbers grow really, really fast. They get much bigger very, very quickly. And then here we are at, I don't even know what this number is, probably 1,836,311,903. Yep. And then all of a sudden, we get this negative number. Sorry. All of a sudden, we get this negative number. Then we get another positive, then we get another negative. Obviously, there's something wrong here. So the issue here is what's called an integer overflow. This is a classic example where you can only store up numbers up to like 2,147,000,000, something like that. I know it's like 2 billion something. And then all of a sudden, we get what's called an integer overflow. This has to do with the way that we represent numbers using binary and a system called the 2's complement, where the first bit, or the leftmost bit in a number, is actually assigning whether a positive or negative number. So if it's a 0, it's a positive number. If it's a 1, it's a negative number. Now, obviously, that works great until we reach the limit of that, again, 2 billion something. And then all of a sudden, we have to use that first bit to assign the next magnitude in that number, and that causes it to be negative. Well, it represents it as negative, which is a problem. In Java, there's a thing called big integer that we can use, which is, go ahead and import that, which is going to help solve that problem. I think that's more intermediate. That's something for another day. But I just wanted to show you these my quick two solutions for the Fibonacci sequence challenge. Again, I'm sure there's plenty wrong with this. I'm sure there's people that have better solutions. I'm sure that there's people who have all sorts of things to say. So please go ahead, comment, like, subscribe, and yeah, we'll see you next time for another coding challenge. Thanks.